I'm back. And here we go. So remember the last thing we talked about? We have our normal distribution and we scored a 72 on a test where the mean was 70 and the standard deviation was 4. So I set that up over here. In this center I have a 70. And then I measured one, because we can fit 3 standard deviations above generally and 3 standard deviations below generally, right? Remember we talked about -3 to +3. The empirical rule told us that. And that's 3 standard deviations on the left and 3 standard deviations on the right, and the scores represented. So 70 to 74, 78, 82, right? I added 4 each time. Then I went the other direction, right? The negative direction. So 66 minus 4 is 62, minus 4 is 58. All right, so that's how our graph looks. Now, we got a 72 on the test. So right here is a 72. Right between a 70 and a 74. There's my 72. So let's just draw a line right here representing where 72 is on our graph. Now a standard normal distribution is also a representation of probabilities. In calculus, they figure the area under the curve. So that's what it is. The total area under this curve is a 1. I'm not going to have you do the calculus for it, but we're going to cheat and use some tables. In the handout notes that I made you, we have tables made up for that. So the last 2 pages were tables. So in order to figure out what percent of students scored less than 72, we have to find the z-score first. So 72 has a z-score. So looking at our formula up here, to do a z-score, I take my value of 72 and put it in for x, because that's the observation, minus the mean of 70 all over 4. So that's 2/4, or we'll call it 0.5. All right, so that's my z-score. So step 1, I found the z-score for my observation. Now we like to write this in proper statistical notation. So the first thing I would do is I'd say, what's the probability that x is less than 72? X is less than 72. All right, so let's do that. Let's write it as probably that x is less than 72. But we decided up here is this isn't going to be an x scale problem anymore. This is going to become a z scale, all right? So a z scale is our normal, standard normal distribution, which you would see in your notes, where 0 is the center and 1 standard deviation and 2 and 3 on one side, -1, -2, -3 on the other side. So if you remember from the empirical rule, plus or minus 1 standard deviation away is about 68% of the data. 2 standard deviations away was 95% of the data. 3 standard deviations away is about 99.7% of the data, or almost everything. So we rarely go beyond that. Sometimes you do, but we rarely do. It's pretty rare. So I express this as a z-score, and my z-score is a 0.5. So hey, it's the same as before. Before it was between 70 and 74. On the z-scale, it's between 0 and 1, right? See how it's halfway between whichever scale I used? So now I'm going to write it in z notation. Now, what's the probability that z is less than 0.5? So 72 as an original value, my original observation, converted to a z-score, it's called 0.5. So I had it written first as an x, now I write it as a z, because it's a z distribution. And we use z tables, okay? Now, to use those tables that have probabilities, if you look at your last two, pages of notes, you will note that you've got tables and they look like this. All right, you've got some numbers to go across the top and numbers to go down the side. All right, so what do those numbers represent? Well, all the numbers inside, these represent probabilities written as a decimal. Okay, they're written as decimals. So a 0.5 would be 50%. And out here represent z-scores with their decimals, right? So we have to take every z-score that we have and write it this way. We have to write it as a digit, a decimal, and then 2 more digits, which would be the tenths and the hundredths. So 0.5 will be written as 0.50. So what they do is they chop it up on this table. The first two are the column. All right, so I need to find 0.5 on my column. And the last digit belongs to the row. So this part's the column, and this part's the row. All right, the column and the row. So I gotta look for the row where I have a 0 up here. And they're all written like 0.00, 0.01, 0.02, 0.03. So just look for that number, right? There'll be the second digit there. Or the third digit in my list, the second decimal. So I'm looking at 0.00. All right, so 0.50 is what I'm looking at. So I find that on my sheet, right? We're gonna go across and go down. And let me grab that here. Let's see if I can get that up here for you to see. I found it this way. Here we go. So we have our 0.5 right here. 0.5. Then on the top I have 0.00. Hey, can you see that? There you go. And that's my probability. So that number was 0.6915. So that number was 0.6915, or the probability that z is less than 0.5 equals 0.6915, or 69.15%. Did I run off the screen? I did. There you go. Can you see that? Percent. So one of the tables here represents everything on the right of the center, and the other table represents everything on the left. So if you look at this one, the little graph on the bottom has values to the right, and our other one has values to the left. So see how that's shaded? It's shaded where it goes across this center line. All right? That's an example of finding the probability with a z-score.